Hi, my name's David Lim. I'm the Head of Consulting Partners for AWS. I must inform some of our audience on some disclaimers associated with this presentation, as we have not yet launched in some regions, and there may be some items presented today that will change or move in timeline. As global workloads accelerate, the need for greater agility and global deployment options have driven the public cloud to become mainstream, and customers view public clouds as a way to gain the flexibility and speed to respond to changing business needs. They want to accelerate innovation and align their costs to the business requirements by managing upfront expenses, operational support, and of course, total cost of ownership. Public cloud is mainstream, and customers desire an integrated and hybrid approach. Forrester predicts that the cloud market will accelerate faster in 2018 as enterprises around the world look to cloud to power their core business systems, in addition to their customer-facing applications. In simple words, organisations are increasingly turning to cloud to gain the business agility and build an edge over competitors. Overall, we look at the public cloud market. Forrester predicts the public cloud market will grow to $236 billion by 2020. Moreover, Gartner also notes that the highest public cloud growth will come from infrastructure as a service, and predicts that by 2020, 90% of organisations will adopt hybrid infrastructure. Hybrid cloud architecture is the integration of on-premise resources with the cloud resources. For most organisations with on-premise technology investments, operating in a hybrid environment and architecture is a necessary part of cloud adoption. Migrating legacy IT systems take time, and therefore selecting a cloud provider who can help you implement a thoughtful hybrid strategy without requiring costly new investments in on-premise hardware and software is important to simplify operations and more easily achieve your business goals. By working closely with enterprises, AWS has developed the industry's broadest set of hybrid capabilities across storage, networking, security, application deployment and management tools to make it easy for you to integrate the cloud as a seamless and secure extension of your existing investments. We've also created strategic partnerships with long-time leaders in on-premise platform providers such as VMware and others to allow you to run your existing enterprise applications on AWS with full support and high performance. Late in 2016, we announced the partnership of VMware and AWS, and this partnership bridges the gap between private and public clouds. AWS is a de facto standard for public cloud. We know how to operate at scale. We provide flexible consumption economics, and we all have the broadest set of cloud services with global scale and reach. VMware provides the leading on-premise compute, storage, and network virtualization capabilities, and VMware is a de facto standard for enterprise data centers as they support a broad range of workloads. Together, VMware Cloud and AWS delivers a seamlessly integrated hybrid cloud solution that extends on-premises VMware environments to AWS's elastic, bare metal infrastructure that is fully integrated as a part of the AWS platform. So what are some of the benefits of this new offering? With just a few clicks, you can rapidly provision VMware environments on AWS. Resources will be operationally consistent with your on-premise vSphere-based environment, and you can use familiar VMware technologies to manage your hybrid environment between cloud and on-premise under a single pane of glass. Additionally, VMware Cloud on AWS is 100% compatible with existing and new enterprise workloads using VMware technology, which is delivered as a service with licensing, lifecycle management, and support from VMware all on one number to call. So take advantage of VMware technologies optimised to run on next-generation AWS infrastructure with optimised access to AWS services and leverage seamless workload portability at scale. This offering runs directly on the dedicated Nitro-based Amazon Electric Cloud Compute, or EC2 bare metal infrastructure that has high bandwidth, advanced security, and low latency. VMware Cloud and AWS also provides enterprise-grade security with micro-segmentation and encryption and allows granular VM-level control without having to maintain the underlying hardware. Flexible and innovative, VMware Cloud on AWS delivers flexibility that will suit your business demands. It aligns to costs, your business needs, with flexible consumption options and investment protection. VMware Cloud on AWS is seamlessly integrated with native AWS services, giving you the VMware technology experience and access to all of the available AWS offerings. It lets you run applications on the cloud without expensive refactoring of code, increases the value of your enterprise applications by giving you access to a broad range of AWS services for integrated application modernisation, and you can capitalise on cloud agility and scale in an operationally consistent and familiar way. In terms of targeted use cases, we have worked with VMware to target 3 categories of use cases, and within each category, many customers want to accelerate to the cloud migration without complex conversions and run their applications on VMware Cloud and AWS. Cloud migrations are ideal for customers who want to move specific applications to the cloud due to specific business needs, or have data centre-wide evacuations, or perhaps want to consolidate data centres and move completely to the cloud. Infrastructure refreshes are also commonplace. Doing infrastructure refreshes, and they want to leverage the opportunity to move to the public cloud, and this may include hardware end of life, infrastructure, software and upgrades to major versions, for instance, a pre-vSphere 6.0 upgrade or a data centre or colo end of lease are all common use cases. Then there's data centre extensions, which allows you to extend your data centre with VMware software-defined data centre into AWS, the world's largest and most experienced public cloud to meet the needs of your production applications. Ideal for customers who require footprint expansion. They may have geographic capacity needs for reasons such as data sovereignty rules, or the need to be closer to their end users and do not want to invest in building out a new data centre, or they do not want to provision net new capacity in their data centres for new projects. On-demand capacity. To really have capacity constraints on-premise to handle seasonal spikes in demand, or the need to handle unplanned temporary capacity needs. And then there's test and development, a need for doing test and development activities in the cloud in an environment that's operationally similar to their on-premise environments. And then there's probably the most common use case of all, disaster recovery, which is delivered as a service for VMware Cloud and AWS, delivering on-demand site protection with native automated orchestration, failover and failback capabilities. So if you want to protect additional workloads to complement your existing DR strategy with a cloud-based DR solution, then VMware Cloud on AWS is a perfect solution for you. In terms of region availability, we'll offer VMware Cloud and AWS across AWS regions, providing a robust and hardened cloud infrastructure to enable compelling use cases over time. With 55 availability zones and 18 global regions, AWS has the largest geographic footprint of any cloud provider. As of now, 2 US-based locations and London are available now. We plan to expand to other areas such as Frankfurt in Q2 this year, and of course the APAC region in Sydney, Q3 2018. This will certainly be an exciting time as we go live with this offering. Both customers and partners can access any of these regional offerings now, and if you have workloads already running in the AWS data centres in the US, EMEA and soon to be ANZ, then you should really consider leveraging the VMware Cloud on AWS platform. I'm now going to hand over to Frank Van, our Partner Solutions Architect for VMware Cloud and AWS, and he will dive deeper into the architecture and use case technical aspects of the solution. Frank, over to you.
Thanks, David. My name is Frank Fan, Solution Architect from AWS. Let's look into the technical details of the components. The environment is completely pre-built and configured by VMware. ESXi is running on bare metal, so this is not nested virtualization. Each of these hosts is equivalent to an i3 16x large instance type. You are going to have 36 CPU cores and ½ terabyte memory. The size of cluster can go from 4 hosts as minimum up to 32 hosts. You can have up to 10 clusters inside the SDDC. You have the ability to scale up and down dynamically. It typically takes low double-digit number of minutes to add a host to a cluster. There are 15 terabyte of NVMe all-flash storage on each host, and the usable capacity is around 10.7 terabyte per host. vSAN is aggregating the NVMe local drives as shared storage. More hosts are required if you need additional storage capacity. NSX is creating the network virtualization layer. Each host has elastic network adapter which provides 25 gigabit bandwidth between the hosts. This is supported by VMware as a cloud service, so VMware is going to take care of things like patching and upgrading virtualization components. So you don't need to deal with compatibility guide anymore. As a customer, you have delegated permission of vCenter to manage your workloads. Let's jump into the network connectivity of this solution. NSX is used to create the network virtualization layer. That means you run overlay networks on top of AWS VPC. There are two types of network in this SDDC: management network and workload network. NSX-H will provision two gateways by default. The management gateway will provide a connectivity for management traffic, such as vCenter and NSX Manager. The compute gateway will provide a gateway access for all of your VM workloads. You can create multiple logical networks, and they all be connected to a compute gateway. AWS Internet Gateway is a device that provides access out from the virtualization layer to the Internet. By default, when you provision this environment, will be prompted to connect to your customer-owned AWS account. How does this connectivity established? This is not VPC peering, as VPC has no visibility of the overlay network created by NSX. On the right-hand side is your customer-owned AWS account. As part of the onboarding process, some elastic network interfaces will be deployed in there. Your AWS account has multiple subnets. You choose the subnet that ENI will be deployed in. The ENIs will be directly connected to the bare metal ESXi hosts. Lots of engineering efforts has been put by both VMware and AWS to make this work. In this example, there are 4 ENIs here, and the route table points to the first ENI on the top. Any traffic to the logical network on the left-hand side will go through this active ENI, then reach the compute gateway resides on the first ESXi host. A very common question we have been asked is, what if you have compute gateway failure or host failure? Do I lose communication between these two environments? In case host 1 fails, another compute gateway will be activated on host 2. In the meantime, the route table will be upgraded and the traffic will be pointed to the new ENI. As a result, you don't lose the connectivity to the workload VMs. You have a customer data center running your bare metal environment today, and you deploy this new VMware Cloud on AWS software-defined data center. How do you actually connect these two environments together? You can build an IPsec VPN tunnel from your on-premise network devices into the compute gateway and management gateway in VMware Cloud on AWS. So this allows you to have that layer 3 connectivity. There is no need to have NSX running on premises for this purpose. You can use any supported device with layer 3 VPN capabilities. What if you need to do vMotion? You need to connect the VM kernel network, which is sitting on the VPC network. You can use Direct Connect to connect with VM kernel network. Besides, you also need to stretch a layer 2 network between your on-premises and VMware Cloud on AWS, so you can vMotion without changing IP addresses. How can we get started? You can log into VMware Cloud on AWS console using credentials provided by VMware. Then, you will be redirected to the AWS login page. Once you're logged into your account, CloudFormation template will be pre-populated. It has an IAM cross-account role with AWS managed policy attached to it. That means you have permission to this IAM role to describe subnets and make some changes, for example, updating route tables. Why is this required by VMware? VMware wants to make it easy for you. Every time when you create a new logical network in VMware software-defined data center, they update route table for you using this cross-account role. For many of you, this may be quite new, so we'll share a short demonstration of the onboarding process. This is the VMware Cloud on AWS console. Once I click Create VMware Cloud as SDDC, you see AWS account with CloudFormation template. Once I go there, I need to log in to AWS account. Once login has been completed, you see the CloudFormation template is pre-populated. You acknowledge it and launch the template. All this does is to create a cross-account role with AWS managed policy attached to it. Now, the CloudFormation stack has been created. Let's go back to the VMware Cloud on AWS console. You will see the connection is successful, which means both accounts now connected. Let's specify SDDC properties. You put in region and number of hosts. Then choose which VPC and subnet you wanted to connect. After that, you choose a private subnet range to be used for vCenter server, NSX manager, and ESXi hosts. Then SDDC will be deployed in VMware Cloud on AWS environment. If you log into the VMware Cloud on AWS console, you will see a cluster already being provisioned here. Let's look at the summary. It shows the utilization of CPU, memory, and storage. You can take actions such as add a host dynamically on demand. It takes low double-digit minutes to get a host provisioned in a cluster. You can also easily remove a host on demand. This gives you full flexibility to just provision capacity as you need. Let's look at settings. You see the vCenter endpoint, which you can log into via web interface. Let's dive into networking details. There are two gateways in the middle. They are management gateway and compute gateway. Layer 3 VPN tunnel has been created between on-premises and management gateway. So you can create a hybrid link mode, which means you have a single pane of glass to manage resources on-premises and VMware Cloud on AWS. Compute gateway is used for the traffic from the workload VMs. Between the compute gateway and connected Amazon VPC, this is a high bandwidth, low latency link created via Elastic Network Interface. It will provide a private link for SDDC to leverage AWS native services. If you scroll down, you will see the firewall rules configured for two gateways. The firewall rules configured in compute gateway control the traffic between the workload VMs and connected AWS VPC. Here, I'm going to introduce a fictitious scenario, company ACME. The company has migrated some multi-tier application from on-premises to VMware Cloud on AWS. There are some opportunities for improvement. They need a backup and DR strategy for both on-premises and VMware Cloud on AWS. The business is growing very fast and the resources are limited. They wanted to ensure the performance and scalability to meet the business needs with minimal architectural changes. Besides, they also wanted to have secure protection for these workloads. Let's start with the first requirement, backup and recovery. This is a simple and low-cost approach that backs up your data and application from anywhere to VMware Cloud on AWS. It's appropriate for less important applications that don't require high business continuity. On the left-hand side is your on-premises data center. The right-hand side is VMware Cloud on AWS. Step 1. Stand up backup server on premises to back up VM data to S3. If your backup vendor is not natively integrated with S3, you can leverage AWS Storage Gateway. You can also use Snowball to load large data set initially. Step 2. Deploy backup software in SDDC in VMware Cloud on AWS. Step 3. Spin up VMs and restore backups from S3 into VMware Cloud on AWS. Step 4. Use Route 53 to switch DNS record to point to new infrastructure. As a result, we use SDDC in VMware Cloud on AWS to replace your failed infrastructure. In addition to the backup and restore approach we just mentioned, is there an approach to meet high business continuity in an automated way? Absolutely. VMware Site Recovery is offered as an add-on to your current VMware Cloud on AWS deployment. It provides simple failover and fallback with one click. VMware Site Recovery can protect the following 3 scenarios. 1. Workloads running in an on-premises data center to a VMware Cloud on AWS SDDC. 2. Workloads running on the VMware Cloud on AWS SDDC to an on-premises data center. And 3. Between different VMware Cloud on AWS SDDCs. Let's look into the requirement 2. When application tier scales out, what would be the best way to present the shared data set to them? You can leverage S3 or Amazon Elastic File System, EFS. Traffic from your VMs can go through Internet Gateway and talk to S3 public endpoint. Another option is to go through ENI on the right-hand side to access S3 VPC endpoint. This is a private link which provides high bandwidth and low latency. And the traffic never leaves AWS infrastructure, which means better security. The same approach for EFS as well. You can mount the EFS volumes to the VMs in VMware Cloud on AWS using the link we just mentioned. For multi-tier application, DB scalability and performance is very important. AWS Relational Database Service, RDS, is available on several database instance types, optimized for memory, performance, or I/O. It provides cost-efficient and resizable capacity while automating time-consuming administration tasks. So you can focus on your application performance. You can connect to RDS via the Elastic Network Interface, which provides performance required for your applications. Let's look into the requirement 3. How would you protect the VMs in VMware Cloud on AWS? What we see customers doing is deploying application load balancer ALB in their custom-owned AWS account and specify the IP range of VM logical network as ALB IP target, which means you can register the VMs behind ALB. The user needs to do is to redirect the DNS record to the ALB. ALB offers a single point of access and line of defense between the Internet and backend applications in VMware Cloud on AWS and customer VPC. Only supports valid TCP requests, so UDP and SYN floods are not able to reach hosted applications. ALB also offloads SSL connections with certificate generated by Amazon Certificate Manager service. We can also leverage other AWS services to better protect your workloads. Route 53 provides name resolution and routing capabilities to protect domain names from DNS-based DDoS attack. CloudFront filters requests to ensure that only valid HTTP or HTTPS requests will be forwarded to backend applications. Requests for your content are automatically routed to the nearest edge location, so content is delivered with the best possible performance. AWS Shield provides always-on, flow-based monitoring of network traffic and active application monitoring to provide near real-time notifications of DDoS attacks. AWS WAF, and more specifically the Web ACL, that acts as a central inspection and decision point for all incoming requests. It provides SQL injection protection, cross-site scripting protection, manual IP blocking, whitelisting, and many other features. We just walked you through the hybrid cloud journey of a fictitious company. They used vMotion to have a seamless migration from on-premises to VMware Cloud on AWS. Beyond that, they integrated with AWS native services to implement DR and backup strategy, improved the scalability and performance of the solution, and provided secure protection for their workloads. Let me hand over back to David.
Thank you, Frank, for that deep dive into the nuts and bolts of the offering. With new features being released every 90 days, there is so much to come as we roll this offering out across the globe. I'm sure you will agree that the VMware Cloud and AWS offering is a fantastic partnership that will benefit our customers who are looking to retire their technical debt and leverage their investments in VMware to drive innovation. It's also a fantastic opportunity for our partners to help our customers accelerate to the AWS cloud. Whether you're evacuating your data center, expanding geographically, or fortifying your platform with DR and high availability, multiple use cases will be a fantastic fit for VMware Cloud on AWS. Be sure to look up more information on any of these websites. To gain more confidence and hands-on experience with AWS, you can access the digital and classroom trainings built and delivered by AWS experts. AWS also has a wide partner ecosystem to help you focus on your success and take full advantage of all business benefits that AWS has to offer. To learn more about our APN partners and to find the right one that fits your needs, please visit the AWS APN booth at our showcase. And thank you for taking time to learn more about VMware Cloud and AWS, and I hope you have gained more insight into this exciting new offering.